Welcome to solverfy.
Hello students. So the question is to find the amount of water which is being produced in this reaction. So here we have been given the amount of butane which is 1.2 gram and the amount of oxygen is given and it is 3.04 gram. So this is the balanced equation of the reaction of the butane when it is being combusted in oxygen to produce CO2 and H2O. So here let's from the balance equation we can see that 2 moles of the butane which is C4H10 requires 13 moles of oxygen to completely act in this reaction. So here let's first calculate. So here we'll be first calculating the moles of butane which is C4H10. So here the number of moles which is N, which is denoted by N, is equal to the weight upon the molar mass. So here the molar mass of the butane which is C4H10 is equal to, so here the C4H10, let's calculate it. So here we have carbon which has 4, so 4 into the atomic mass of carbon which is 12 plus the atomic mass of hydrogen which is 1 into 10. So it is equal to 58 gram per mole. Now let's put the value of the molar mass and the weight so we can calculate the number of moles of C4H10. So it is equal to, so the weight of the butane is given and it is 1.2 gram divided by its molar mass which is 58 gram per mole. So by calculating we'll get the number of moles and it is equal to 0.0206 moles. Now similarly we will be calculating secondly in the moles of oxygen. So here the number of moles of oxygen is equal to the amount which is 3.04 gram divided by the amount the molar mass of oxygen which is 32 gram per mole. So here the number of mole calculated is 0.095 moles. So this is the actual moles. So now we will be calculating the theoretical moles. So here to calculate the theoretical moles of oxygen, as we can see from this relation that 1 mole of the butane which is C4H10 requires 13 upon 2 moles of oxygen. So we have 0.0206 moles of the C4H10. So it will require how many moles of oxygen? So we'll simply cross multiply it. So here we have 13 upon 2 multiply by 0.0206 moles. So we'll get 0.1339 moles. So this is the theoretical moles. So as we can see that the theoretical moles is comparatively more than the actual moles which is present. So here we can conclude that the limiting reagent is the oxygen because we have lesser the amount than the theoretical moles of the oxygen. So the amount of the H2O production will depend on the oxygen. So from the equation we can see that 13 moles of oxygen will produce 10 moles of water. So 1 mole of oxygen will produce 10 by 13 moles of the water. So here we have the actual moles, which is 0.095 moles. So the 0.095 moles of the oxygen will produce how many moles of water? So we'll simply cross multiply it. So we'll get 10 by 13 into 0.095 moles. So the number of moles of water will produce from the 0.095 moles of oxygen is 0.730 moles of water. So here, as we know, the number of moles of is equal to the weight, or we can say the amount, divided by the molar mass. So from here we can calculate the amount of water produced, and it is equal to the number of moles into molar mass. So by putting the value we can get the amount of water, and it is equal to 13.14 grams. So this is the answer. I hope you find this video helpful. Thank you.